Next topic we are going to see is about energy in simple harmonic motion. For finding out with the energy, we are going to find the expression for potential energy, then the expression for kinetic energy, then we'll be finding with the total energy. Okay, adding with the kinetic as well as the potential energies. Okay, first for simple harmonic motion, the force and the displacement are related by the Hooke's equation as we know F proportional to x, same way F proportional to r. So we are writing as F is equal to minus k into r, and if you are writing as x, we get F is equal to minus k into x. And the potential energy can also be written as F is equal to minus du divided by dx. This is the equation for potential energy, which is F is equal to minus du divided by dx. Now just comparing with these two equations, both the sides we have the term F, so these two can be equated. Minus du by dx is equal to minus kx, both the sides minus get cancelled. X we are going to bring it to other side, so we get du is equal to kx into dx. From this you need the value of u, so we have here du, is not so? We have to integrate the other side. If you integrate, we get integration of k x dash dx dash. Why are writing as x dash and dx dash is because we have here the value as 0 to x. Okay, so we are writing as x dash dx dash. Okay, now if we write the formula for integration of x into dx, okay, so the formula for x into dx, it is x square divided by 2. If we have just dx, it is equal to x. Okay, x into dx, that is equal to what? X square by 2. So this can be written as x dash square divided by 2. Now apply the limit in this. How to apply the limit is upper limit minus lower limit. So x square minus 0 square. So 0 square is neglected. We are having just half into k x square. Okay. Now substitute the value of k is equal to m into omega square. Okay, substituting the value of k is equal to what? M into omega square. So we get u, which is equal to half as it is. Instead of k, we write it as m omega square into, already we have with the term x square here, so x square. Yes, clear? Here omega is said to be the natural frequency of the particle. Yes, and generally, we know the formula for x. X is equal to what? A sine omega t. Is it not? And this x, if you substitute it here, we get half omega square into this term fully square. So a square sine square omega t. Okay, so half omega square a square sine square omega t. So this gives the equation for the potential energy. Yes, clear? Then next is we have the equation for the kinetic energy. Yes, so for finding out the kinetic energy, the formula we are taking is half m into v square. Yes, now this v can be written as v is equal to, the formula is dx divided by dt. Okay, so dx divided by dt the whole square. Yes, and what is the formula for x? Just now we saw, which is a sine omega t. It's not. And now this a sine omega t, if you are going to substitute in the place of x here, so we get v, which is equal to d divided by dt of a sine omega t. Yes, so we are going to differentiate in this equation. We are going to differentiate. A is constant, so writing as it is. When you differentiate with this sine omega t, the formula is sine, if you differentiate, it is cos omega t. Okay, again if you are differentiating with this omega t, we get omega in the front. So a omega into cos omega t. Okay, so this gives the equation for v. Okay, having this equation, taking with this same equation again. Okay, from this, what is sine omega t? That is x is equal to a into sine omega t. If you need the value of sine omega t alone, we can bring this down. Okay, so it is x divided by a. Okay, so this gives the value of sine omega t. Here what is the value we need is cos omega t. Okay, so what is the formula is cos square theta, which is equal to 1 minus sine square theta. This equation you know, is it not? From this, if you want cos theta, bring this square this side, so we get root of 1 minus sine square theta. Yes, clear. Square we are bringing here. So this becomes as root of. Now, instead of theta, if you write as omega t, so cos omega t, which is equal to root of 1 minus sine square omega t. Okay, what is sine omega t? We know is x by a. So sine square omega t is what? So squaring this. Okay, so it is x divided by a the whole square. Okay, so substitute the value of sine here. So we get root of 1 minus x divided by a the whole square. So this gives a value of cos omega t. That value we are going to substitute it here. Okay, so 1 minus x divided by a the whole square. Okay, then taking LCM here. Okay, just square this and take the LCM. So 1 minus x square divided by a square. If you square this, we get 1 minus x square divided by a square, is it not? Now take LCM here. So we get a square minus x square because we'll be multiplying this term here. So a square minus x square divided by a square. Okay, so this is the equation which we get when we take the LCM. Okay, so what is the equation is a omega as it is, then inside this we have a square minus x square divided by a square. Now bring this a square outside so that the square root and square get cancelled, so we get a omega divided by a into root of a square minus x square. Okay, now both the values of a get cancelled, so we get omega into root of a square minus x square. So this gives a value of v. Yes, so substituting this value of v now in this equation. Okay, so this is half m into v square, is not? So instead of v, if you substitute this here, so square is this square and square root get cancelled, so we get half m omega square into a square minus x square. Okay, yes, now if you multiply this inside, so we get half m omega square a square minus half m omega square x square. Either we can write it in that way, or what we can do is this a square minus x square we are writing as a square into cos square omega t. Yes, clear. Now, if we see the graph for this potential as well as the kinetic energy, okay, potential it is in the positive direction only, okay. Then here it is starting from the maximum. This potential is starting from 0. Here it is starting from maximum, okay. 0 it is just increasing, from maximum it is decreasing, okay. So this is the equation for the kinetic energy. Clear? Now we are going to write what is the total energy. Total energy is equal to what? Kinetic plus potential. Okay. Kinetic is half m omega square a square minus x square plus potential is half m omega square x square. Okay. Now cancelling with the term of x square in this. Okay. So x square if we cancel, we get half m omega square a square alone, because if we multiply this inside, multiplying this term inside, we get half m omega square a square minus this term, if you are multiplying here, we get half m omega square into x square. Then writing this term as it is, so we get plus half m omega square into x square. Yes, this term is plus and this term is minus, the same term, so we are cancelling this. So the remaining is half m omega square a square. So that gives a value of total energy. So this is a total energy value. Okay. So same way, if you are writing this sine and cos terms, if you are writing with the sine and the cos terms, half m omega square sine square omega t, this is for potential energy and this is for kinetic energy. Yes, and among this half m omega square a square is common, taking this outside. The remaining is sine square omega t plus cos square. So what is the formula for sine square theta plus cos square theta, which is equal to what? 1. So instead of theta we are writing as omega t, so sine square omega t plus cos square omega t is 1. So this term fully becomes as 1, so we get half m omega square a square. Okay, and if we draw the graph For the total energy, as we know, the potential energy is starting from 0 and it is increasing, is not? And the kinetic energy is starting from maximum and it is decreasing. So this gives a value of the total energy because it is a combination of kinetic as well as a potential energy. Yes, clear with this? Okay. Thank you.